Now the 13th one, SBI data. This asks the processor to subtract the immediate data along with the carry status content of the carry status flag from the content of the accumulator and place the result in the accumulator register. This is also a 2-byte instruction since this data happens to be a 1-byte data. So SBI needed to have a 1-byte code. So this will be stored in the program in 2 consecutive memory locations. The first location will have the operation code for SBI that will be fetched in the opcode fetch machine cycle at the expenditure of 3 consecutive T states, and the 4th T state of opcode fetch, that is the first T state of the execution cycle, this instruction will be decoded. Upon decoding, the processor will identify that 2 operands involved in these instructions are readily available within the processor. These are the content of the accumulator and content of the carry status flag. And there is one more operand that happens to be the immediate data being present in the next memory location of the program that needed to be brought to the temporary register associated with the ALU of the processor, and that require a memory read operation, so that there will be a total of 2 different machine cycles, opcode fetch and memory read. Overall, there will be 7 different T states. Addressing mode for this one is implicit. For this one, it is register addressing mode. And for this operand, the operand itself is given as an immediate data, hence immediate addressing mode. Once again, all status flags will be affected. So these are the various instructions associated with the different kinds of addition and subtraction operations. Now we have some increment decrement operation, incrementing the content of the register. There's also a basic instruction performed by the ALU of 8085 microprocessor. I hope you will be able to recall that the ALU is capable of performing 10 different arithmetic or logical operations. One among these involved incrementing or decrementing the content of a register or a memory, etc. etc. The first one in this category is INRR, that happens to be the 14th instruction in the arithmetic group. INRR asks the microprocessor to increment the content of the register whose symbol is mentioned as the opcode of the instruction by 1. Say for example, it can be INRB that asks the processor to increment the content of the register B by unity and place the result in this register. So it can be INRC or INRE, any general purpose register could be used. This is a 1-byte instruction. Instruction will be completed in opcode fetch operation itself in the 4th T state. Upon decoding, the processor will identify that the operand happens to be content of the register present within the microprocessor that needed to be incremented by unity or that needed to be incremented. Overall, there will be 4 different T states. Now, addressing mode. Operand happens to be content of a register. To represent that operand, symbol of the register is being mentioned. Hence, addressing mode is register addressing mode. Now, these instructions affect all the status flags except carry. That means it affects all flags except carry, or carry status is not affected. However, all the remaining 4 out of the total 5 will be affected. Now INRM. This asks the processor to increment the content of the memory location pointed by HL pair by unity. This is also a 1-byte instruction. However, this requires a total of 3 consecutive machine cycles. The first machine cycle opcode for INRM will be brought. That is the opcode fetch machine cycle. In the 4th T state, this will be decoded. Upon decoding, the processor will identify that the operand happens to be the content of the memory pointed by HL pair. So from that memory, this content needed to be brought to the interior of the processor. That will be placed in the temporary register or in the accumulator. Then the content will be incremented by 1. Now again, this needed to be placed back to the memory location pointed by HL pair. So this require a total of opcode fetch for fetching the operation code of INRM, memory read to bring the content of the memory location for the number that is now present outside the processor to the interior of the processor. Then it will be incremented by 1, and this must be written back to the same memory location. So overall there will be opcode fetch, memory read and memory write machine cycles. This will have 4 different T states, plus memory read and memory write require 3 different T states. So 3 plus 3 plus 4 make it say 10 different T states. Now addressing mode is HL pair is used indirectly for addressing the operand present in the memory location. So it's register indirect addressing mode. Here also all the status flags except carry will be affected. Now decrement operation, DCRR, decrementing the content of the register whose symbol is mentioned in the instruction by unity. 1 byte instruction, only opcode fetch is required for T state, register addressing mode, all except carry will be affected. Now DCRM, this asks the processor to decrement the content of the memory location pointed by HL pair by unity and place the result back to this memory location. Content of HL is written using 1 square bracket and content of this memory is being shown at the expenditure of 1 more square bracket. അപ്പോൾ ഈ ഒരു കേസിലും ആദ്യം ആ മെമ്മറി ലൊക്കേഷനിൽ ഒക്കോഡ് കൊണ്ടുവരണം. ആദ്യം DCRMന്റെ ഒക്കോഡ് കൊണ്ടുവരണം. നാലാമത്തെ T സ്റ്റേറ്റിൽ ഡീകോഡ് ചെയ്യുമ്പോൾ പ്രോസസ്സറിന് മനസ്സിലാകും ഒരു മെമ്മറി ലൊക്കേഷൻ ഉണ്ട്. ആ മെമ്മറി ലൊക്കേഷൻ്റെ അഡ്രസ്സ് HL പെയറിൽ ഇരിപ്പുണ്ട്. ആ മെമ്മറി ലൊക്കേഷനിലിരിക്കുന്ന നമ്പർ പ്രോസസ്സറിൻ്റെ അകത്തേക്ക് കൊണ്ടുവരണം. എന്നിട്ട് അതൊന്ന് കുറയ്ക്കണം. എന്നിട്ട് തിരിച്ച് ആ നമ്പർ ആ മെമ്മറി ലൊക്കേഷനിൽ തന്നെ കൊണ്ടുപോയിട്ട് വെക്കുകയും വേണം. അപ്പോൾ ഒരു മെമ്മറി റീഡ് നടത്തി ആ നമ്പർ ഇങ്ങോട്ട് കൊണ്ടുവരണം. പിന്നെ അത് കുറയ്ക്കും. അതിനൊരു T സ്റ്റേറ്റ് ഈ എക്സിക്യൂഷൻ്റെ ഭാഗമായിട്ടുള്ള ഇമ്മീഡിയറ്റ് T സ്റ്റേറ്റ്, ഒരു T സ്റ്റേറ്റ് പോലും ഇല്ല എന്ന് തന്നെ പറയാം. പിന്നെ അത് തിരിച്ച് ആ മെമ്മറി ലൊക്കേഷനിലേക്ക് റൈറ്റ് ചെയ്യുകയും വേണം. അപ്പോൾ മെമ്മറി റൈറ്റും വേണം. Often this instruction will be used in your problem session for drawing its timing diagram. So you'll have to keep in mind that there is a total of 3 different machine cycles and a total of 10 different T states. These machine cycles are opcode fetch, memory read and memory write. So the relevant status lines needed to be shown changing once there is change from opcode fetch to memory read and then from memory read to memory write, while you are going to draw the timing diagram for this kind of instructions, or for specifically these 2 instructions, INRM and DCRM. Addressing mode, register indirect addressing mode, all except carry will be affected. Now incrementing the content of a register pair, that's a 16-bit number, will be incremented by 1. INX RP. RP corresponds to the symbol for the register pair. Upon seeing this letter X in the mnemonics, it's vivid that it's a register pair. It's a symbol for a register pair. We have already seen it in LXI, data transfer group of instruction LXI register pair. So this asks the processor to increment the content of the register pair whose symbol is mentioned as the operation code or operand of the instruction, not operation code but the operand of the instruction by unity. അപ്പോൾ ഇതിനകത്ത് സംഭവിക്കുക, ഏത് രജിസ്റ്റർ പെയർ ആണോ ഇവിടെ സൂചിപ്പിച്ചത്, ബി ആണെങ്കിൽ BC രജിസ്റ്റർ പെയർ, BC രജിസ്റ്റർ പെയറിലെ കണ്ടന്റിനെ ഒന്ന് കൂട്ടിയിട്ട് അവിടെ തന്നെ വെക്കും. അപ്പോൾ ഓപ്പറന്റ് പ്രോസസ്സറിനകത്ത് തന്നെയാണുള്ളത്, ഒപ്കോഡ് ഫെച്ച് മാത്രം മതി. പക്ഷേ ഇതൊരു രജിസ്റ്റർ പെയറിലെ കണ്ടന്റ് കൂട്ടുന്നതായതുകൊണ്ട് 4 T സ്റ്റേറ്റ് പോരാ, 2 വെയിറ്റ് T സ്റ്റേറ്റും കൂടെ ഈ ഓപ്പറേഷൻ തീർക്കുന്നതിന് വേണ്ടിയിട്ട് സ്പെൻഡ് ചെയ്യും. ഓവറാൾ ദർ വിൽ ബി 6 ഡിഫറെൻറ്റ് T സ്റ്റേറ്റ്സ്. അഡ്രസ്സിംഗ് മോഡ് രജിസ്റ്ററിന്റെ സിമ്പിൾ പറഞ്ഞേക്കുന്നു, രജിസ്റ്റർ അഡ്രസ്സിംഗ് മോഡാണ്. ഈ 2 ഇൻസ്ട്രക്ഷൻസ് പക്ഷേ ഒരു സ്റ്റാറ്റസ് ഫ്ലാഗിനെയും അഫക്റ്റ് ചെയ്യുന്നില്ല. We'll have to keep in mind because in some programming pieces we'll have to take care of these instructions, INX register pair and DCX register pair, that affect no status flags. Now DCX register pair. This asks the processor to decrement the content of the register pair whose symbol is mentioned in the instruction by unity. This is also a 1-byte instruction. Opcode fetchil തന്നെ ആ ഇൻസ്ട്രക്ഷൻ തീരും. പക്ഷേ രജിസ്റ്റർ പെയറിലെ കണ്ടന്റിനെ മുഴുവനായിട്ട് കുറക്കാനുള്ളത് കൊണ്ട് ഒരു രജിസ്റ്ററിലെ കണ്ടന്റ് കുറക്കുന്നത് പോലെ പെട്ടെന്ന് ചെയ്ത് തീരുകയില്ല. There will be 2 more wait T states. So overall it requires 4 T states for opcode fetch and decoding and 2 wait T states, making it say a total of 6 T states for the instruction for completing or performing the activity specified by the instruction. Addressing mode, once again register addressing mode. No status flag are affected. Now the last one in this category, arithmetic group of instruction, that is decimal adjust accumulator. 8085 microprocessor is a processor that has a word length of 8. So often the content will be coded with the help of hexadecimal code, so that all the operations that we perform will be performed over hexadecimal numbers, and the result present in the accumulator will be hexadecimal result. However, often we will have to make use of this microprocessor to perform operations performed, particularly additions performed upon decimal numbers, because practically we often make use of decimal operations rather than hexadecimal operation. So the content of the accumulator immediately after an addition operation will be available as a hexadecimal data, but often we require this as a decimal content. To convert this hexadecimal data to the corresponding decimal number, we will be making use of this instruction decimal adjust accumulator. This asks the processor to convert the hexadecimal data present in the accumulator to the decimal. Here I have made a mistake. Decimal to hexadecimal alla, hexadecimal ആയിട്ടുള്ള റിസൾട്ടിനെ ഡെസിമലിലേക്ക് മാറ്റുന്നതിന് വേണ്ടിയിട്ടാണ് ഈ ഇൻസ്ട്രക്ഷൻ യൂസ് ചെയ്യുന്നത്. It's a 1-byte instruction. There is only a requirement of opcode fetch. Operand is already present within the processor, within the accumulator itself, and the operation will be performed all at a sudden. Overall, the requirement is for different T states. And the addressing mode is implicit addressing mode, because the operand happens to be the content of the accumulator that is already known to the processor. In some textbooks, it is being written as a register addressing mode, in the sense that this A corresponds to decimal adjust accumulator. Here A corresponds to register. So register addressing mode can also be imparted for this instruction. All status flags will be affected. So this is about the 20 basic instructions coming under the category of arithmetic group of instructions. We have now already seen 13 data transfer group of instructions and 20 arithmetic group, overall 33 basic instructions. Now we will move on to logical group of instructions.